Hi everyone, Mr. Allen here. I'm just going to go over the solutions from the cumulative practice problems. I've basically cut each of the solutions that I posted onto a separate sheet here, and I'll just kind of talk through each one, hopefully a minute at most for each of them. One sort of thing to note before I get started, I sort of wrote up here in the corner for many of these alternate solutions giving the same answer is possible. So basically recognize that what I've done is kind of one method of getting to an answer, probably what I think is the quickest or the shortest method, but that there will often be other possibilities, and I'll sort of hopefully mention them as we kind of go through. First question just says use a tree diagram to list all the possible outcomes, or a listing here. So basically two possibilities. This is the tree diagram. Initially on the tree diagram I've got nothing, so that's kind of the top of the tree. So up here, there's nothing that's happened. And then on the first roll, so I sort of indicated the first roll here, but the numbering is not necessarily, doesn't necessarily have to be there. I get a head or a tail. Following that, I can get, of course, a head or a tail on each of the subsequent rolls as well. So following this head, I could then get a head or a tail. Following getting tails on the first roll, I could get heads or tails. And then, of course, on my third roll, I could have had two heads and then a head or a tail, and so on and so forth. So just kind of the tree diagram allows you to see across the bottom the number of possibilities here, this head. And then if you wanted to take it a little further and you wanted to figure out how many combinations here, or how many situations here, sorry, did we get exactly two heads, you can just kind of follow the paths, right? So there's two heads there. There's two heads there. There are two heads there. Oh, and that's all the possibilities. So 3 out of the 8 possibilities give us two rolls that were, or two flips that were exactly heads. The other possibility here is just list them off. I could get heads, heads, heads. I could get heads, heads, tails. I could get and sort of list them off. And hopefully we see that we have 1, 2, 3, that same 3 possibilities where we get exactly two heads. Now that's kind of that next step, sort of recognizing what is the probability of each of the different possibilities. What is the probability that I flip exactly 3 heads? Well, only 1 out of those 8 possibilities has that situation. We didn't quite get there yet, but sort of that's where we're leading eventually. License plate. So somebody asked me the question, if you don't know, can license plate numbers and letters be repeated? The answer is yes. But what we'll assume on any of these questions is if I don't specifically state that repeats are not allowed, you can always assume that the situation will be repeats are allowed. So in this case, I would explain if they were not allowed so that you knew, because I don't necessarily know that you pay enough attention to license plates to recognize that there are repeats and so on. So basically, license plates consist of either 3 letters or numbers, or 4 letters, 3 letters and 3 numbers, or 4 letters and 3 numbers. How many different license plates can be used? So we have 2 situations here, the one where we have 3 letters only, and one where we have 4 letters. And of course, they have to be handled differently because you just sort of can't discuss 2 different situations at the same time. So the 3 letters, basically, we can have 26, 26, 26, 26. Followed by the 3 numbers, and the 4-letter ones, there are 26 times to the 4, 26 times 26 times 26 times 26 possibilities for that letter, for those letters, and then 10 cubed again here. And then basically, because they are separate situations, all of these are legitimate cases, all of these are legitimate cases, we add them up to get the total. Committees. So at this point, we're looking at a combination versus a permutation. The question really we want to ask ourselves is, does the order in which the committee members are chosen matter? So I have my students, call them A, B, C, D. So those are my 12 students, and I'm looking to form a committee. If I happen to randomly choose B, H, K, or I happen to choose K first, then B, then H, the question we want to ask ourselves is the committee different because K was chosen first instead of B? And if it's just a committee, then it doesn't make a difference. So in the first case, we have 12 options. We want to choose any three of them. That is in case you're sort of still not sure, yeah, so over here, that's 12, choose three, that's the combination. The second case, though, is of course the one where the ordering matters. If I pick this person first, or if I assign this person that position, then the position clearly matters. And so that's the permutation. So this question specifically was on here to try to clarify the difference there, or to emphasize the difference between a committee where Bob, Mary, and Joe are all the same, or an executive where Bob is the president, Mary is the secretary, Joe is the treasurer, versus Mary is the president, Joe is the secretary, Bob is the treasurer, versus, and so on. So all those different situations where the people are ordered differently matter in this case, do not matter in this case. So committees, again, sort of same situation. How many committees can be formed by 3 men and 2 women from 8 men and 6 women? So basically we're looking to kind of get some sort of a balance here. The two groups are unique, but they still only form one committee. So we have to choose 3 men from the group of 8, 2 women from the group of 6, and then because they are forming the committee together, it's a multiplication. This is not 2 separate groups that are being both considered legitimate groups. This is 2 parts of the one group I'm looking for. Okay, so here's one where we start to get some specifics. So in this case, Mrs. Jones and Mr. Jones are not apparently happy. They don't want to be together, or maybe they're the president and vice president, and we can't have both of them in the committee, something along those lines. So in total, if there are 15 people and no restrictions at all, there would be 1,365 committees. Just look at the 15 people, randomly choose 4. That's your number of possibilities. The number of groups that have both of them in the committee. So if we sort of say, well, I'm going to put Mrs. Jones and Mr. Jones on the committee automatically, that means I only have 2 other positions that need to be filled from the 13 remaining people. And so there are 78 committees out of this large number. Only 78 of them have both people on it. And so if we subtract that from my total number, we know how many groups are legitimate and do not contain both Mr. Jones and Ms. Jones. I changed the Ms. because I was sort of getting answers from 2 different spots. The other possibility, of course, is you could look at all the situations that occur that do not contain this 78. So you could sort of think about, we'll put Miss Jones on, and then we would need so if Miss Jones is on, we want to not allow Mr. Jones to be on. So that leaves me 13 people from whom I need to choose 3. So Miss Jones is already on. Mr. Jones is not being considered. So there are 13 choose 3 ways to get committees that have Miss Jones, but not Mr. Jones. Similarly, a completely separate group, Mr. Jones could be put on the committee. Miss Jones would be eliminated from the list, and then there would be 13 choose 3 more ways to sort of pick a committee that has Mr. Jones but not Miss Jones. And then we could also sort of think, well, as long as if neither one of them's on it, that's perfectly fine too. So I could just pick my entire committee out of the 13 other people and get these 3 possibilities to give me that same value here. So committees that have just Miss Jones but not Mr. Jones, just Mr. Jones but not Miss Jones, and neither one of them would make up this 1287. And if you fire that off in a calculator, hopefully you get the same answer.